Welcome to PowerGenius Certified Installer Training. In this module we're going to be looking at installing the variable appliance controller onto a hot water cylinder. So we'll check the cylinder first, turn the thermostat up to full, mounting the controller, installing the temperature sensors, some basics around wiring, and then the default configuration set up in the dashboard and testing before you leave site. The very first thing to do when you get onto a site that you're going to install a PowerGenius hot water controller onto is check the hot water cylinder. Check that it has a tempering valve or a mixing valve. Check that it has a TPR valve, which is the temperature pressure relief valve, and then if it does have both of those, immediately turn the thermostat up to full. You should hear a click as this turns on. The hot water controller is designed to be installed next to the hot water cylinder, mainly because you need to run temperature sensors from the controller and mount them in the hot water cylinder. Usually there is enough space in a cylinder cupboard or in a ceiling space or on the outside of the building next to the hot water cylinder to mount the controller. One of the key points of difference is the temperature sensor. In fact, the PowerGenius hot water control system uses two temperature sensors, one at the bottom of the cylinder and one halfway up. The reason is that it is a hot water cylinder and the key word is hot. The other reasons are that it gives you far better optimization of solar energy that we'll look at shortly, and also for compliance around Legionellas. We're going to now watch a video of the actual installation of the middle temperature sensor. The PowerGenius is one of the only systems in the world that uses the middle temperature sensor for optimization, so this is something that is very important to get right. Using a 32mm or 40mm hole saw, designed not to be able to penetrate the hole once it's drilled, carefully drill the outer skin of the cylinder. Use a knife blade to separate the part of the insulation that you're going to remove to install the temperature sensor. The blade should gently score down the inside tank. Then remove the insulation, but make sure you hold on to the insulation for later on because you're going to need to put it back. Once you've removed enough insulation, you'll be able to see the inner tank, and then you'll be able to insert the temperature sensor down and force it down against the insulation and the inside tank so that it ends up sitting flat against the inside of the tank. It's very important at this point to make sure that the sensor is bedded in hard against the inside of the tank. Once you've made sure that the sensor is hard against the tank and touching nicely, replace the insulation material that you removed prior and leave a little bit of slack on the cable so that if any damage or someone pulls the cable in the future years to come, it doesn't pull the sensor away from the tank. And finally, be sure to completely seal the hole so that there is no airflow from the outside to the sensor. And then place the box over the hole and using short screws, carefully screw the box onto the outside of the cylinder, attach the conduit and run that down to the controller. The whole install should normally take you around about 5 to 7 minutes. So again, the temperature sensor should be touching the inside skin of the tank. Be careful not to drill right through the tank. It's never been done before and you don't want to be the first guy that does it. And make sure that that sensor is not going to be pulled out by the lead if someone trips over it or knocks the box off in the future, or even opens the box and gives the lead a little bit of a pull. So in photographs again, it's quite good to check the drill depth before you drill. So I use the opening of the tank where the thermostat and the element are and just hold the drill there and make sure the mandrel's not going to touch the tank. Then carefully drill the outer skin, clear away the insulation. You can put your screwdriver down to clear a pocket for the sensor, and then once you've installed the sensor, have a look. I put a camera and the light on my phone and just have a good look in there and make sure it's sitting hard against the side of the tank. The key with the sensors is that we need to get good, accurate temperature measurements without penetrating the tank, of course. Completely sealing the hole back up and putting the insulation back in there does two things. It stops the air from circulating around the temperature sensor and giving a false reading, but it also stops moisture getting into that hole if the tank is mounted outdoors. Really important to make a nice tidy job of it because you want a happy customer. The other sensor is a lot easier to mount. There's no need to drill a hole, you just use the opening that's already there and mount the sensor again between the insulation and the tank, and make sure it's mounted between the level of the element and the level of the thermostat. This will then comply with the Legionella's sterilisation legislation that all cylinders are required to comply with. So let's have a look at why the PowerGenius system uses two temperature sensors. Bearing in mind it's going to take you 5 to 7 minutes more on the job to install that middle temperature sensor. The benefits to the customer of having the temperature sensor in the middle and being able to optimize accordingly are huge, and in often cases can save the customer about $150 to $200 more energy every year. There are other training and technical resources available from the PowerGenius website that will help you to understand how these savings are made. So let's have a quick look at how not to install a temperature sensor. Unless of course you love coming back to the customer's place and you get on well with them and you just want to go back and fix it up later on, have a nice chat. But don't leave a gap between the tank and the sensor. Don't just dangle the sensor into the insulation void, and definitely don't put the sensor at right angles to the tank. Here's an installation showing the data coming off two sensors on the same tank where the middle sensor has been installed at right angles to the tank. As you can see, there is 16 degrees difference between the lower sensor and the upper sensor. This will disable the PowerGenius optimization algorithm as it falls back to trying to sterilize the tank after 1 week of operation. The system will not optimize solar if the two temperature sensors are not installed correctly. As you can see from this information, this is the same tank after the middle temperature sensor has been adjusted, and the two temperatures are now within 0.1 degrees of each other. So if you remember at the beginning of this training module, we talked about the temperature of the thermostat being turned right up to the maximum after you've checked for a TPR valve and a mixing valve. This is the reason why. You want the water in the tank to be even, and you want it to be warm right the way through every level of the tank, so you can check that both sensors are bedded in well. The other reason for turning the thermostat right up to maximum is so that you know that the thermostat will not turn off below 60 degrees Celsius, which is the legal minimum requirement for sterilization to stop the Legionella's bug from forming inside the tank. So let's look at the wiring connections of the PowerGenius controller. Initially, the hot water cylinder will just have an isolator and probably flexible conduit with high temperature cabling going to the cylinder. All you need to do is connect the hot water controller between the isolator and the hot water cylinder. There are neutral and earth terminals on the controller, and both of these need to be connected. And the phase cable will come in and be connected at the line, and the active cable going to the hot water cylinder will be connected to the load output of the controller. The load output of the controller should always be connected to the lower element, and if you have a hot water cylinder with two elements, then the upper element can be connected to the auxiliary output if need be, and you can select the default hot water cylinder two elements in provisioning. Once you've connected up all the wiring and the temperature sensors, you can now turn the controller on, and you'll notice that there are three lights: comms, status and fault light. Once the controller has established a link to the gateway, the comms and status lights will flash intermittently. If this doesn't happen, then you need to make sure that the gateway has the correct network configuration downloaded to it, and also make sure that the controller is within wireless range. If not, you may need to add a network repeater or a high gain antenna. Once the communications have been established, you can then update the node logic application and trigger the node configuration. Once this is done, it will normally take about 3 to 5 minutes for the application to download into the node. This is a one-time event, and once it's completed, you'll notice that the modules on the dashboard light up and start reporting data. If this doesn't complete in the expected time, you can click on the update queue and you can see if there have been any problems with this update going through or previous updates that may be holding it up. And finally, before leaving site, it is essential to do all the tests to satisfy yourself that the whole network is running as it should be. Firstly, make sure that the thermostat on the hot water cylinder doesn't turn the element off lower than 65 degrees. If it does, then there will be problems with optimization, and also the PowerGenius will not be able to sterilize the cylinder properly. Check that the hot water cylinder temperature sensors are reading very close to each other, either when they are heating the cylinder and the whole cylinder is heating and both temperatures are climbing, or when it's finished heating, both temperatures should be sitting at within 2 degrees Celsius of each other. Make sure there's a TPR valve and a tempering valve on the hot water cylinder. The thermostat is turned up to maximum. Check that the hot water cylinder is receiving the proportional control signal from the PMM. So go to the dashboard, navigate to the PMM, click on proportional control and manually set that to 50%. Then navigate to the hot water cylinder, turn it on, and then after 5 minutes or so you will notice that the hot water cylinder is running the element at about 50% power. Once you've proven that the hot water cylinder is following the proportional control signal, you can reset the proportional control and the hot water cylinder back to automatic.